Okay, we're going to go over arithmetic sequences. Here's the general formula for arithmetic sequences, and if we're using them recursively, these are some of the formulas we use. Let's read what we have, because this is a difficult question, okay? In an arithmetic sequence, so we know we're in the right boat here, the second term is equal to 25, and the 11th term is 79, okay? How many terms of the sequence are less than 200? So there's a lot of important information here. Let's highlight it. The second term is 25, okay? The 11th term is 79, and then the last bit of information, they want to know how many terms, so how many terms are less than 200, okay? 3 separate but important pieces of information. We're going to take our first formula here, okay? We're going to take this first formula here, and we're going to use some substitution in it. Okay, so this is our term value is equal to the first term plus the term number, subtract 1 times what our addition is happening, what we're increasing by. So the second term refers to our n value. This is our second term. So in this case, n is equal to 2. Okay, and our Tn, this is our term value, Tn is equal to 25. So let's write that in our first formula here. I'll call this formula 1. 25, so we replace Tn with 25, is equal to A plus 2 minus 1 times D. In our second formula, n is equal to 11, and Tn is equal to 79. So our second formula here, 79 is equal to A is still unknown, plus n is 11 minus 1 times D. So if you notice, I've rewritten the same formula, but I have a different value for Tn in n in the first one, and Tn in n in the second one. Okay, and that's where we got our information from. We need to solve for A and D. Okay, so with this information, what we're going to do is we're going to set this equal to a letter and substitute in. Okay, so what I'm going to do here is I'm going to set this equal to, I'm going to set this equal to the letter A, just to start, okay, so that we have a value of A. So in order to do that, I need to move all of this, and I can actually simplify this to the other side. So I am going to simplify it. So let's continue here. 25 equals A. That's just going to be 1. So what's 1 times D?
It's A. D is the way of A, right?
Yeah, so it's just going to be D. 1 times D is D. Okay, and to isolate for A, like we said we're going to do, I'm going to move D to the other side. Okay. And when it goes over there, it becomes negative. Yeah, so I get 25 minus D equals A, which is really important for us. Because now that I know what A is equal to, I can substitute in for this A value. So I'm going to plug this 25 minus D in for the A over here. So this is our equation 2 also. 79 is equal to, I'm going to replace A with 25 minus D. Okay, plus, I can simplify this. What is 11 minus 1?
10.
10, so we get 10D. Okay, so I'm going to write this all in blue now, and we're going to collect our like terms. 79 is equal to 25 minus D plus 10D. Okay, I can collect these like terms. This is like negative 1D. Wait, so negative 1D. Okay, so our negative 1D plus 10D, if you take a calculator out, that's going to be 90. So I have 79 equals 25 plus 9D. The goal is to get D all by itself. Okay, so we want to get D by itself.
Is that over here 25 take away?
So we got to move the 25 to the other side. So when I move it to the other side, it'll become negative. 79 minus 25 equals 9D. Okay. When we do that, we're going to end up at 30, 49, I think it's going to be 54. We better use a calculator just to make sure, but I think it's 54. Let's do 79 minus 25. 54. Great. So we get 54. 54 is equal to 9D. And the goal is to get D by itself. So because this is 9 times D, okay, we have to divide both sides by 9. So what's going to happen here is D will be equal to 6. So we figured out D to start. Okay, so like we're saying, we have D equals 6. So we're going to put it into our first formula here. Our first formula, formula 1 is 25 minus d is equal to a. So we can now take this 6 and replace the value of d with it. So we'll get 25 subtract 6 is equal to our a term. Oh, there we go, our a term. So in this case, I need to see something. Okay, good. 25 minus 6 is actually 21. So our a term is equal to 21. So this is really important. Our formula stated that Tn is equal to a, recall, plus our n minus 1, okay, times d. We now have a whole bunch of the information. D equals 6. A equals 21. That's really important. Those are the most important stuff right now. And we had a whole bunch of other info we connected. Remember, at one point we knew Tn was 79 when n was 11. And we knew Tn was 25 when n was 2. So that's great. Now that we have these pieces of information, we need to figure out how many of them are less than 200. Okay?
Yeah.
We can use an inequality to do this, or we can do some trial and error. Okay? If we were to do an inequality, we need to figure out at what value will be less than 200 in this question. So what we can do is we can replace Tn, okay, that's this value here, with the value of 200, but instead of saying equals, we can say 200 is greater than all of this stuff on the right. Okay, so a.
Oh, because it can't go over 200.
That's right, because it can't go over 200. Is n minus 1, and d value was 6. Great. So the goal will be to isolate n. We need n to be less than whatever that is. So 6 technically needs to be distributed here. Okay, if you remember your distributive property. So we get 200 is greater than 21. This becomes positive 6n and minus 6. We are going to collect our two like terms, which these are these two constants here. Okay, 21 and negative 6. So that'll say 200 is greater than 21 minus 6 is actually 15 plus 6n. I need to move 16 to the other side of the equation, and when we do that, it'll become negative. So 200 minus 15 is greater than our 6n. 200 minus 15 is going to give us 185. It's greater than 6n. And to get n by itself, we need to bring 6 over and divide by 6.
Yeah, divide by 6.
So when we divide by 6, we're actually going to get 3. So we're going to get 30 point. We should bring out a calculator, I guess, for this. 185 divided by 6. 30.8. 30.8 is greater than n. So what the heck does that mean? Well, remember they were asking us how many terms were less than 200. So what it's saying is the 30.8th term is equal to 200. Okay, 30.8th term equals 200. But okay, we only work in whole numbers.
Yeah.
So we should test our 30th term to make sure that it's less than 200 in our original formula, and that's that would be this formula here where we plugged in a and d. So we're going to try it again. Okay, so our term number is unknown, is equal to a. A is what we started with, which was 21, plus our n is 30 in this case. We're going to test to see that 30 is under 200. So we're going to place the value of n with 30 minus 1. And remember, d is equal to 6. We'd figured that out. Okay. T at n is equal to 21 plus 30 minus 1 is 29 times 6. So this part I can do all with my calculator here. Okay. So 29 times 6 equals plus 21 equals 195. Okay. So Tn equals 195. Is that less than 200?
Yeah.
Yeah, it is. And because we're increasing by 6s every time, that works out perfect. So 30 terms. Yeah, 30 terms. My calculator is going really slow here. Terms are less than 200. Sorry, it's kind of lagging there. Let's go to full screen.